Hello, good day. Today we are going to discuss the ordinary annuity as a continuation of our previous lecture video. And to start with, we have now this illustrative problem number 1. A chemical engineer wishes to set up a special fund by making uniform, semi-annual, and of period deposits for 20 years. And the fund is to provide 100,000 pesos at the end of each of the last 5 years of the 20-year period. If the interest is 8% compounded semi-annually, what is the required semi-annual deposit to be made? Okay, so based on this problem, we are given with this 20-year period, but we are also considering semi-annual compoundings at 8%. And for this last 5 years, at the end of each of the last 5 years of this 20-year period, we have now this fund, to provide 100,000. So actually, we are dealing here with deposits, the cash flow deposits, and we have also now the cash flow withdrawal, since this is cash outflow actually in this problem. We have now this simple cash flow diagram for the deposits. Okay, so we have here from 0 year until the actually it is until the 20-year period, but due to this compoundings which is semi-annual, so we just have this m times n, and m is just 2, and then our n is 20 years, so this is just equal now to 40 years now for this cash flow for deposits. Okay, and we have also now this cash flow for the withdrawals. Since this 100,000 based on the problem is to provide maybe for the purpose of cash outflow given, which is a cash outflow from this from the fund itself. Okay, so we have here based on the problem is for each of the last 5 years of this 20-year period. So starting with the 16th year, the 17th, 18th, the 19th, and the 20th year, we have now this cash outflow actually of 100,000 pesos. Okay, so we have now this cash flow for deposits and the cash flow for withdrawals. Okay, and we take note that the annuity is paid in every 6 months, every year for 20 years, or these semi-annual compoundings. But the fund is to provide 100,000 at the end of each of the last 5 years. So take note of this one, at the end of each of the last 5 years, meaning this is referring now to annual semi-compoundings. That is why we have here from 16th until the 20th year. Okay, so for 2 or more nominal rates to be equivalent, their effective rates must be equal, since we are dealing here with semi-annual and this annual compoundings. Okay, so we have now to determine now the ERI, actually the effective rates of interest. But we have now this cash flow, this cash flow going downward for the deposits, with this annuity until the 40th years because of the semi-annual compoundings. And above this one is we have now this cash outflow from the 16th, 17th, 18th, 19th, and the 20th year with this 100,000 pesos. Okay, so since we are dealing with semi-annual and annual compoundings, we need actually to determine the ERI of this annual and semi-annual compoundings. Okay, So let's start with this ERI actually, no? ERI for this annual, okay? Annual compounding is equal now to the ERI of this semi-annual, okay? So from the formula, we have now this 1 plus the ratio of R over M, okay? And then we raise this one to the M minus 1 for this annual, okay? Which is just equal now to this 1 plus the ratio R over M raised to the M minus 1 for this semi-annual, okay? So from the given, actually, the value of our R here, the nominal rates of interest is unknown. And the only given value for this nominal rate of interest is for this R of the semi-annual, which is actually equal now to 8%. So substituting, so we have now this 1 plus R, and then since this is annual, so over 1, and then raise now this one to the 1 minus 1, okay? Which is equal now to this 1 plus our R here is 8% or 0.08 divided by 2 since this is a semi-annual, and we raise this one to the squared minus 1, okay, for this semi-annual. And we have now this R here equal to 0.0816, or in percent is just equal now to 8.16%, okay? So we're done, no, with the nominal rate of interest for this annual compounding, okay? So what shall we do now? According to the problem is we are going to determine actually the value of our annuity, okay, because we are dealing with this semi-annual deposit. So what shall we do now? Actually, we are going to consider the equation of value, no, for this case. So we are using this equation of value actually, okay? So according to this equation of value, this one set of obligation, no, is just equal now to the sum of the other set of obligation actually. So we have now discussed deposit here, this cash flow diagram with this annuity for semi-annual annuity, and we have now this another set of obligation here, which is the cash withdrawal from the 16th year until the 20th year, okay? So we are dealing here with this equation of value. So based on this one, actually we need to consider now the using 20 years from today, actually from today as the focal date, okay? So we have now this formula for, since this one is given and this one is unknown, so actually you can consider, no, the the the, the first, not the first case, no, if we are dealing with that papa, or shall we use the second case now for this papa? Okay, so in this problem, it's better for us now to use the papa actually. Okay, in which this is referring now to this future worth equal now to this annuity, then this f given a at I% and periods. Okay, so actually this is case number 2 no, from our previous lecture, and for this one this is just a designation actually. Okay, so this is just equivalent to our f given a at I% and period is just equal now to, it is just equal to 1 plus I raised to the n minus 1 all over I actually. Okay, so this would be it now. So substituting this one, f is equals to a, and then this one with this value, so we have now this 1 plus I raised now to the n minus 1 all over this I. Okay, so based on this equation of value, this cash flow for the deposit is just equal now to this another set of obligation, which is now the cash flow for the withdrawal. Okay, so we can therefore say that our cash flow for deposit is just equal now to our withdrawal actually. Okay, so using this equation for this f equal now to annuity times this 1 plus I raised to the n minus 1 all over I, so we are actually having this 1. Okay, so for the deposit, we are considering this cash flow here for this annuity going down. Okay, so this is just equal now to annuity A, okay, times we have now this 1 plus I, okay, 1 plus I, then raised now to the n minus 1 all over I. Okay, is equal now to this cash withdrawal here. We have here 100 no, so our A here is 100,000 actually, so we have 100,000 times this quantity 1 plus I raised now to the n minus 1 all over I. Okay, so simplifying, so we have now here A is just equal now, okay, rather let's erase this one. This would be equal then to A times here our I is just equal now to 0.08%. Actually this is 8% no, in decimal point 0.08 divided by, since this deposit is having a semi-annual compounding, so this is over 2 actually. Okay, and then raise now this one 2, so this n will be now equal now to m times n, which is 2 times 20. Okay, and then minus 1 all over our I, which is 0.08 divided by 2. Okay, which is then equal now to this 100,000. Okay, times this quantity here. So 1 plus our I here is 8.16%, no? This one. So we have here 0.0816, and our compounding is just annual, so 1. This is 1, and raise this one to the power of 1 times. So since we are dealing with here with this set of obligations, so our end here is just 5 years. So 5 times 1 is just 1 times 5, okay? Minus 1 all over this 0.0816 divided by 1 actually. Okay, so this is minus 1 here. Okay, so proceeding, so we have now this value of our equation of a times the result of this one is about 95.0255 actually, equal now to this 588,535. Okay, so we have now this value of our semi-annual payment of equal to A is just equal now to 6,193 pesos. Okay, so this would be it now for this problem. Using now this equation of value and using the case number 2 no, for this given annuity and this cash outflow 100,000 using the FAFA actually. So this is now our answer now for this problem, which is equal now to 6,193 pesos. Okay, so proceeding, we have now this another illustrative problem, number 2 actually. So a businessman needs 50,000 for his operations, and one financial institution is willing to lend him the money for 1 year at 12.5% interest per annum, and this is discounted. And another lender is charging 14% with the principal and interest payable at the end of 1 year. And a third financial lender is willing to lend him 50,000 pesos payable in 12 equal monthly installments of 4,600. So which offer is best for him? Okay, so actually in this problem we are going to calculate now the effective rate of interest or the ERI, and then the ERI having the less value no, is the best offer for this problem. So actually we need to calculate the ERI for the first, the second, and the third financer in this problem actually. So for the first one, so our approach will be, first we are going to study the first offer no, with this one financial institution willing to lend him the money for 1 year at 12.5% interest per annum. Okay, so for this first lender, okay, so we have now this value of our, actually this 12.5% is our small d no, the rate of discount. Okay, so we have here the small d is just simply equal to 12.5%, which is now this is now the rate of discount actually. Okay, so after this one, we have the formula, no, from our previous lecture also, that in order to get now the value of our interest rate actually, so we have this formula also, which is I is just equal now to this d over 1 minus this rate of discount, which is then equal now to 0.125 over 1 minus 0.125. So our I here is just simply equal now to 14.29%. Okay, so this would be now our rate of interest, no, for this first lender. Next, we are going to compute the ERI actually. So from our formula is we have this ERI equal now to 1 plus actually I raised now to the m minus 1, in which we have now already this value of our I. So this would be equal to 1 plus 0.1429, and then we are going to raise this one to the 1 since we are dealing per annum here. Okay, so minus 1. So our ERI is then equal now to still 14.29%. Okay, so take note of this ERI now for our first lender, which is just equal now to 14.29%. For our second lender, we have now here, okay, the second lender. So based on the given, we have this value of our R actually, no, which is with this 14% with the principal and interest payable at the end of 1 year. Okay, so from here we have this value of our R actually. So our I is just simply equal now to R here, since we are dealing here with an annual compoundings, no, at the end of 1 year. So I is just equal to R, which is equal now to 14%. Okay, so calculating now the ERI, so its ERI is just equal now to 1 plus 0.14. Then okay, so excuse me, so we need to erase this one, no? So this would be ERI is just equal now to 1 plus 0.14, then raise this one now to the 1 minus 1. Okay, so we have now our ERI equal now to, actually this is 14%. Okay, so we are done with the second lender. So our first lender is 14.29 and our second lender is about 14% only. And for our third lender is third lender. Okay. So based on this third financier or lender, third financier is willing to lend him 50,000 pesos, no? Payable in 12 equal monthly installments. So this equal monthly installments will be referring now to this annuity of 4,600 pesos. So willing to lend him this 50,000. Actually, this 50,000 is our principal or the present worth. So actually, we can use, no, since the present worth or the principal amount is given. Actually, we can go directly, no, with the formula that we have, no, in our previous lecture, in which we are considering here case number one, since our installment is given with this A equals to 4,600 and this P for the principal of 50,000 pesos. Using the formula, no, for case number one, which we are dealing with the word Papa, meaning this is P equal to A, and then with this designation of P given A at I% and N periods. Okay, I hope you will still remember this one always, no. Case number one, Papa. So substituting here, so we have P is equal to A times this quantity 1 plus I raised now to the n minus 1 all over 1 plus I raised to the n times this I actually. Okay, so the P is given, the unit is given, and also the n is given, no, for 12 equal monthly installments. So meaning it is also given. Okay, so proceeding, so we have now this P of 50,000. Okay, equal now to annuity is 4,600 times this quantity here. So 1 plus our unknown here is I, then raise now to this 12 minus 1 over 1 plus I raise now to the 12 times this value of our I. Okay, so calculating the value of our I here, actually we have this I equal now to 0.0157, or our I is simply equal now to 1.57%. Okay, so we are done now with our I, so we need to calculate again each ERI. Okay, so each ERI is just simply equal now to 1 plus 0.0157, then you raise this 1 to the 12, then minus 1. So our ERI is just simply equal now to 0.2056, or in percent equal now to 20.56%. Okay, so comparing now our ERI, so for our first ERI 1 for the first lender is just equal now to 14.29%. And for our ARI2, which is referring now to the second lender, this is just equal now to 14%. Okay. And for our ARI3, referring now to our third lender, which is equal now to 20.56%. So according now to the principle of the engineering economy, the lowest ERI will be now the best offer. So in this case, we have now this second ERI actually, which is now the lowest. Okay, so this would be now the best offer, no, which is the second financier actually. So we can label this one as, this will be now the best offer actually, referring now to the second financier, and this will be now our answer for this illustrative problem number 2. Okay, so proceeding, we have now this last illustrative problem number 3. The officers and board of directors of the Philippine Institute of Civil Engineers, or the PICE, desire to award a 3,600 pesos scholarship annually to deserving civil engineering students for as long as its scholarship fund shall last. The fund was started July 1, 1987 by a donor in the amount of 18,000 pesos. So actually, this will be now our principal amount, no? And the PICE invested this amount at that time at 8% per annum and plans on adding 600 pesos each year to the fund from its dues starting July 1, 1998. So this 600 pesos, no, which will be now our cash deposit, will start, no, on July 1, 1988. So a year after this July 1, 1987 actually, for as long as awards are made. Question number 1 is, for how many years starting July 1, 1998 can the scholarship be awarded? And second is, what will be the balance in the fund after the last award is made? Okay, so I think this is an interesting problem actually. This is a very interesting problem, no? And to start with this one, we have this as part of our solution for this A. We have now this 18,000 pesos, no, which I said as our principal, in which a donor, no, this was donated by a certain donor in this amount at 0 period. Okay, so this 0 period is referring now to July 1, 1987. And on the first year, based on the problem, is the PICE invested this amount, no, this 18,000 pesos at the time at 8% per annum, and plans on adding 600 each year to the fund from its dues starting July 1, 1998. So this is July 1, 1998, which is our first year. So this is the start of this 600 pesos actually, no. Okay, so until such a year until the nth year. So we do not know, no, when the scholarship fund shall last. Okay, so this is now a simple cash flow for our deposits actually. And proceeding, so this is also now for our withdrawals, no, the cash flow for withdrawals, because we have withdrawals because of this 3,600 pesos, because according to this one, the PICE desired to award a 3,600 pesos scholarship annually to deserving civil engineering students, meaning this is just a cash outflow on the side of the PICE organization. So that is why this is going upward, no, because this is now a cash outflow, okay, going out from the pocket of the PICE organization. So they will start giving this 3,600 from the very first year, no, on July 1, 1998 until the nth year, okay. And we have now this cash flow for deposits and withdrawals. So this is now our first diagram now shown from the previous slide, and this is now our for the cash flow of our withdrawals actually. Okay, so as you can observe, no, so we can have a net of this value, no, so 3,600 minus 600. So actually we have a net cash flow for this. Okay, this will be now our net cash flow of 3,600 minus 600, so this will be 3,000. So prevailing is this amount since this is bigger than this cash deposit actually. So we have now this net cash flow for our problem. Okay, so calculating now the value of our n here, since we do not know yet, no, what will be now our n based on this cash flow actually. So actually based on this one, we have this P and we have now this uniform installment, no, in which we consider this one as annuity. We can actually use the formula, no, for our case number 1. Okay, again, the case number 1 papa is very applicable here. Okay, which is P is equal now to the annuity, and then we have now this again 1 plus I raised now to the n minus 1 all over 1 plus I raised to the n times this I actually. Okay, and take note that we have now this value of our I, no, our I is simply equal now to 8% given in the problem. So proceeding, P is 18,000 actually, so 18,000 is equal now to annuity of 3,000. Okay, times, okay, so times this quantity here. Okay, so we do not know yet, no, the value of our I, so rather the value of our n with this given I. So we have here 1 plus 0.08, then raised now to the n minus 1. Okay, all over 1 plus 0.08 raised now to the n times this. Our I is 0.08. Okay, so calculating now the value of our n here using your calculator, so we can get now the value of n, which is just equal now to, actually this is 0.52 equal now to 1.08 raised now to the negative n, in which our n here is just simply equal now to 8.5 years. Okay, so this would be now the value of our n actually equal now to 8.5 years. So for 8 years and this 6 months, so the fund is expected to end, no, maybe if there are some excess amount of this fund, maybe it's quite tolerable, no, in a lesser amount. So it is expected that in 8.5 years, the fund of the PIC organization is expected to be at equal to 0, or maybe almost zero. Okay, so we are done with our first question, and next is we are going to the next, no, to the next question. Okay, so since we calculated now this n is equal now to 8.5 years, so we have here very simple, no, cash flow, considering now the future worth, no, here with this 8.5 years as the value of our n, in which we have now this 3,000 here as our annuity, and we have also here with our principal of 18,000 pesos. Okay, so as you can observe here, we have now this formula, no, for case number 2, FAFA actually. So F is equal now to annuity with this F given I percent in periods, in which here our annuity is 3,000. Okay, and we are only dealing with this case number 2 F, since we are going into this value of F, no, at 8.5 years here. Okay, this is now another set of obligation actually, and for this cash, no, cash, actually this is a cash deposit, no, this 18,000 pesos is just another set also of obligation, no, and its formula is we are dealing with this F given P at I percent in N period, since we are going now to determine actually the future worth of this principal amount 18,000 pesos, no. So take note, we are going to calculate the future worth of this given principal amount of 18,000, and we are going to equate this one to this future amount also, using this 3,000 as our annuity, and with this n equal now to 8.5 and our interest of 8%. Okay, so actually we are using here the equation of value actually. So here we have using the equation of value actually. So if you are going to consider first, no, this 18,000, calculating now the future amount, so this would be F equal now to P times this 1 plus I raised now to the n. Okay, so F is just equal now to given P of 18,000 times 1 plus our I is 0.08, okay, times our n of 8 point, rather 8% actually. Okay, so this is 8.5, where our 8% is our I. So calculating now the value of our F is just simply equal now to how much? This is 34,623.78 pesos. Okay, so we can denote actually this one as F subscript 1 here. Okay, so this is considering this 18,000 pesos as our principal. So how about if we are considering this 3,000 as our annuity here for this cash here for this cash flow, no, above this one. So we will denote this one as F2 actually. So we are going to use this FAFA actually. Okay, F given a I percent in periods, and then we have now this F equal now to annuity of 3,000 times this 1 plus I, which is 0.08, okay, raised now to the n of 8.5 minus 1, okay, minus 1 all over our 0.08, okay. Okay, so we have the value of f here is equal to, this is our actually f2, okay. This would be equal now to 34,632.87 pesos, okay. So we have now this f2 here actually for considering this 3,000 as annuity, okay. So as you can observe, there's a presence here of this x. So actually, if we try to determine the difference of this one, so our x will be now equal to this f2 minus this f1, okay, which is then equal now to 34,632.87 pesos minus this f1, which is 34,623.78. So our x here is just simply equal now to about how much will be our x here? About 9 pesos and 09 centavos. Okay. So based on this one, we can say that the amount of money remain in the fund of the PICE organization is only 9 pesos and 09 centavo actually. So it's almost done, no? We have it's almost having no money in their account actually. So within this 8.5 years, so it is expected actually that their money is almost equal now to zero. Okay, so I think this would be it, no, for our second question, no, with regards to this problem, and I think this would be it, no, for this day. We have tackled three additional illustrative problems, no, for this topic, ordinary annuity. And before we end, no, this would be now my references, no, again, Santa Maria and of Mandawi and Kaputi. And please like, share, and subscribe for more updated videos, no, regarding this subject. And once again, thank you very much for listening and watching, and God bless us all.